Welcome back. Dale Myers with Student Advance. In this video, we're going to talk about electron energy and the energy given off when electrons move from one energy state to another and how that relates to the wavelength. And you might remember that the amount of energy as you get closer, so here on our picture here, we see that we have, this is the Bohr model of a hydrogen atom with the nucleus right here in the center, okay? Um, Closer to the center, you are at lower energy. And this is the first energy level of electrons here. This is the second energy, third, fourth, and so on and so forth, right? So moving away from the center, we get more energy. Well, but let's say an electron gets excited and or let's say we have an excited electron, rather, that's in electron shell 2. It gives off a photon of light, and it drops down to n equals 1, energy level 1. That photon of light, if we follow this arrow, this line right here, has a wavelength of about 122, I'm pretty sure this is like nanometers, right? So that's going from energy level 2 down to 1. We give off a photon of light that happens to have a wavelength of 122. So now the next thing is, well, what if I went from energy level 3, so here we are, energy level 3, and I dropped down to level 1? This case, I gave off a little more energy, and I happen to have a wavelength of 103. If you remember the relationship between energy and wavelength. If energy or frequency goes up, the wavelength goes down. So even though we gave off more energy going from 3 back down to 1, we have a shorter wavelength. And by the way, the wavelength is in this area up here, which is, it's called the Lyman series, but specifically it's UV light. It's UV light. So if you have a homework assignment and you're asked to talk about how much energy is given off, or well, so that's the numbers down at the bottom represent the amount of energy given off in this particular example. And you sometimes have to figure out what wavelength of what part of the visible or electromagnetic spectrum does that fall into. So let's look at some additional examples. So if I ask you, going from, say, n equal 4 down to n equals 2. So I need to find an electron at energy level 4. And so I go to energy level 4, and I just go around the circle. And this one is at 4, but this one's going back to 1. That's not the one that I want. So I go back here, and I find another one. This one goes back to 2. And if I follow my line, that's 486 nanometers. So again, so I would say that the energy given off has a wavelength of about 486 nanometers, right? And again, this goes the same thing here. Like, so if I was at energy level 6 and went to energy level 3, well, here's 6 going down to 3, it gives off that amount, something with a wavelength of 1094. Again, it happens to fall in the infrared spectrum. So again, just kind of want to take a quick look to show you guys how this all works. This assumes that you really understand, again, a little bit more about frequency and wavelength. This is kind of an advanced, somewhat advanced concept. But if that's still confusing, leave a comment, let me know, and I can go back and brush up and tighten up all the loose ends here. But again, this was just meant to show you how to read this diagram and, again, relate it to how much energy is given off and what's the wavelength of that energy, which spectrum, which part of the electromagnetic spectrum does it fall in? Is it in the infrared spectrum, the visible light spectrum, the UV spectrum? And again, your teacher may have talked about the Lyman series, which again corresponds to wavelength in the UV spectrum. The Balmer series corresponds to wavelength in the visible for the most part, and then the Passion series. So again, my name is Dale Myers with Student Advance. Have any further questions, or your teacher said something a little different, feel free to leave a comment. Guys, take care. And please, we're just starting out. Go ahead and subscribe, and if you need some requests, drop a comment, and we'll try to get that out to you. Thank you.